So today we'll be covering polynomials. So what are polynomials? So before we get into details, we're going to ask ourselves, when we divide any number, let's say we divide 15 divide by 5, we get 3. Now when we divide any number, we always get a quotient. This is a quotient, and sometimes we also get a remainder. So now polynomials mainly, and the remainder theorem mainly gets its basis from those ones that have a remainder. So now let's start. We see what is a polynomial. Let's first define a polynomial. A polynomial is an algebraic expression made by adding, subtracting, or multiplying terms that contain variables raised to whole number powers. So now we can have linear polynomials where here the highest degree of the variable is 1. For example, they can be written in the form of ax plus b. So here you see that the power of the variable is 1. The highest power of the variable is 1. In quadratic, the highest power of the variable is 2. This is a quadratic equation. This is a linear polynomial. This is quadratic. Then now for cubic, the highest power of the variable is 3. So you have ax cubed plus bx squared plus c. So it's ax cubed plus bx squared plus cx plus d. This is cubic. Then quartic, which is degree 4, is ax to the power 4 plus bx cubed plus cx squared plus dx plus e. So we have this. So for this is a linear polynomial. You see the highest power of x is 1, quadratic the highest power of x is 2, cubic the highest power of x is 3, quartic the highest power of x is 4. Now in this x is representing the variable, and the variable could be anything. It could be ay plus b, where y is the variable, but now here in all these cases x is the variable. So the highest power of the variable determines what type of equation it is. If the highest power is 2, it's a quadratic. If the highest power is 3, it's a cubic. If the highest power is 4, it's a quartic. Okay, now let's look at the remainder theorem. So we said when you divide any two numbers, usually you get a quotient and sometimes you get a remainder. For example, if you say 15 divided by 5, you get 3. This is a quotient. Now here, if you say 15 divided by 4, this is the quotient and this is the remainder. If you divide 15 by 4, you get 3 remainder 3. This is a quotient plus a remainder. So we can rearrange this, bring this inside. So this is 15 is equals to 3. Sorry, 4 times 3. This is like the dividend, what is dividing, then times the quotient. So meaning all functions with remainders, we can always express them as that function. In this case, the function is 15 being equal to 4, which is like the dividend here, into this should be into q, where q is representing the quotient plus the remainder. Now, this is going to be our basis for all these numbers, that when we get any function, we can express it as the product of the dividend, in this what is dividing, here it's 4, and then the quotient plus the remainder. And so we've seen that this makes sense. For this case, the function would be 15 being equals to 4, what the dividend times the quotient, what you get after dividing 3, plus the remainder, which is 3. So this is 12 plus 3, so you see it's 15. Now let's look at this example. So the question is asking us to find the remainder when this is divided by x minus 1. So how do we go about this? The first thing we get here, this is our function. So what is our function? 6x cubed plus 7x squared minus 15x plus 4 is equals to, now this is the dividend, the way we said here. So it's equals to this times the quotient, which we don't know, like what you get after dividing, plus the remainder. So this is what we're going to always be for it. Now, for this case, you realize we can eliminate this such that we just have remainder is equals to something here by equating this to 0. So if you equate x minus 1 to 0, so this is 0 times q, so this term goes out. So here x would be 1. So we can substitute this x here and we say 6 into 1 cubed plus 7 into 1 squared minus 15 into this plus 4 is equals to the remainder. So you see we've eliminated this. But how did we eliminate it? How did we eliminate it? We equate x minus 1 to 0, so x is 1. Then now we substitute this into this, then now we can get the remainder. So here we have this is 6 plus 7 minus 15 plus 4 is equals to the remainder of this question. Now here we can use our calculators. 6 plus 7 minus 15 plus 4. So we have 2 is our remainder. Now we have another way we can do it, and that's using the long division method. So here I would like you to take keen interest in this. So this is our division sign. We have 6x cubed plus 7x squared minus 15x plus 4, and we are dividing it by x minus 1. So we're going to have here a small side work for the first number, but for the other numbers I think we would now be ready to follow. Now every time we are doing long division, we are always going to focus on removing that coefficient we are dealing with, that term we are dealing with at the moment. Now in this case, we want to eliminate 6x cubed. So we can now, and this is the term we are using this first term to eliminate the term we want to eliminate. So here we have 6x cubed being the first term we want to eliminate. Then here we have, we divide it by x. What do you get? 6x squared. So here I come and say 6x squared. Then I multiply it by this. 6x squared, I multiply it by x, I get 6x cubed. Then again I multiply it by minus 1, so this is minus 6x squared. So I hope you see what I'm saying. That's the reason we are dividing to get 6x squared, so that when we multiply here we get 6x cubed. Then we can eliminate. We are eliminating one term at a go as we divide. Now here we do this, so we subtract. Here we have 7 minus minus 6. 7 minus minus 6, that becomes 7 plus 6. 7 plus 6, this is 13x squared. Then we now carry all these. Then plus 4. Then I will go to the next term. Here we have 13x squared. So if you have 13x squared, actually we are eliminating one term at a go. So if we want to eliminate 13x squared, we get this 13x squared. Then we divide it by this. Divide it by x. What do we get? 13x. So here we have plus 13x. Then we now multiply this throughout this entire term. We have this is 13x squared minus 13x. Do this. Then I will subtract. 13 minus 13 is 0. Then we have negative 15 minus minus 13. So that's the same as negative 15 plus 13. So what do we get? We get negative 2x plus 4. So we now want to eliminate this. So we said same thing, negative 2x divided by x. What do we get? Negative 2. So now we have minus 2. Multiply minus 2 through everything. So we have minus 2x plus 2. We subtract everything. So minus 2 minus minus 2, it becomes minus 2 plus 2, this goes, and 4 minus 2 is 2. So this is the remainder. So here we can still say remainder is 2. So we found the same answer. Here we found the remainder is 2. Then here we found that the remainder is 2. Okay, so now let's look at our second example. So the question says, find the remainder when this is divided by this. So like we said last time, we get the expression, in this case it's the function, sorry, plus 5x. We equate it to the x plus 1, which is the dividend, then now the quotient q, which we don't know, plus the remainder. So we eliminate this by saying x plus 1 equals to 0, so x is equals to negative 1. Then I substitute this into this, squared plus 5 into negative 1 plus 3 is equals to the remainder. So what do we have here? We have negative 2 minus 3 minus 5 plus 3 is equals to the remainder. So we put it to our calculator. Negative 2 minus 3 minus 5 plus 3 is negative 7. So negative 7 is the remainder. Though now we can also use our long division method. So we have this. So we draw a long division sign, then we put in 2x cubed minus 3x squared plus 5x plus 3. Then this is x plus 1. So like I told you last time, we are always trying to eliminate this, the term on the left hand side, on the outermost left side. So we are going to say 2x cubed out of x. What do we get? We get 2x squared. So this is 2x squared. So we divide 2x cubed by x, we get 2x squared. So we put 2x squared here. Then we multiply 2x squared times x, we get 2x cubed. Then now when we bring this also becomes plus 2x squared. Then we subtract. So here 2 minus 2 is goes. Then negative 3 minus 2x squared. What do we get? Negative 5x squared. We carry the rest plus 5x plus 3. Okay, then now we have negative 5x. We divide it by x. What do we get? Negative 5x. So now here I bring a negative 5x. So then I multiply this through here. Negative 5x times x is negative 5x squared. Then negative 5x times 1 is negative 5x. Then I subtract. So negative 5 minus negative 5. This goes, so then now 5 minus 5, this becomes 10x plus 3. Then now I have what's 10x divided by x? Here I get 10. So plus 10, then I multiply through here by 10. I get 10x plus 10. Then I subtract. So here I have 10x minus 10x 0. 3 minus 10 is negative 7, which is the remainder. So the remainder is negative 7. Okay, so we see here negative 7, negative 7. So it's the same. Then now here I have x cubed minus this. Find the remainder when this is divided by this. So the first thing we get our function. We equate it to be the product of the dividend, which is x minus 3 times the quotient plus the remainder. So we eliminate this by saying x minus 3 is equals to 0. Then x is 3, so we substitute this 3 minus 7. So these are two different methods we are seeing of finding the remainder. This is equals to the remainder. Then now we have this is 3 cubed. This is 27 minus 63 plus 18 plus 1 is equals to the remainder. So this is 27 minus 63 plus 18 plus 1. So we get negative 17 is the remainder. Then now we have this. So we have x cubed minus 7. So this is the second method plus 6x plus 1. So come here on our side back. I divide by x minus 3. So we say x cubed divided by x. What do we get? X squared. So here I put x squared. Then now I multiply x squared by this. So we get x cubed minus 3x squared. I subtract. So here I get negative 7 plus 3. So here what we get? Negative 4x squared. Then I carry the rest plus 6x plus 1. Then move to the next term. Negative 4x squared divided by x. What do we get? Negative 4x. So here I put negative 4x. Multiply it through by this. I get negative 4x squared plus 12x. I subtract everything. So here this goes. Then I have 6 minus 12. 6 minus 12 is negative 6x. I carry this. So when I say negative 6x divided by x, what do I get? Negative 6. So here I have negative 6. So I multiply through by negative 6. So you get negative 6x plus 18. Subtract. This goes. So what is our answer? Negative 17. So our remainder is negative 17. Okay. Now let's move on. So these I think are some numbers we can try out. You can try out this. The question is find the remainder when this is divided by this. Try the two methods. they can help you to verify your answer and try this. Now you're going to a different set of questions. Here we have the remainder obtained when this is divided by this is equal to the remainder obtained when the same expression is divided by this. So the first thing we say, this is 3x cubed minus 6x squared plus ax minus 1 is being divided by x plus 1 plus a remainder, because I said the remainder obtained. So when we divide this by this, we get a remainder which we don't know. So let's first substitute and see. So x plus 1 is 0. X is equals to negative 1. So here we've eliminated this. We then substitute. Get this squared plus a into negative 1 minus 1 is equals to the remainder. So here we have negative 3 minus 6 minus a minus 1 is equals to the remainder. So this is minus 3. This becomes negative 10 minus a is equals to the remainder. So this is the first remainder, because they say the remainder obtained when this is divided by this. So this is the first. Then now it's equal to the remainder obtained when the same expression is divided by this. So now we see what is the remainder obtained when the same expression plus ax minus 1 when the same expression is divided by x minus 3 plus a remainder. So here we say x minus 3 is 0. We are eliminating this. So x is 3. Then we can now substitute 3 into 3 cubed minus 6 into 3 squared plus a into 3 minus 1 is equals to the remainder. So now here, this is just us substituting it to our calculator. So here we get 81 minus 54 plus 3a minus 1 is equals to the remainder. So we have, just put this into your calculator, you get 26 plus 3a is equals to the remainder. But now the question says that the remainder obtained when the first expression is divided by the function is the same as this remainder, so they are the same. So we are going to equate equation 1 to equation 2. So we're going to say negative 10 minus a is equals to 26 plus 3a. Okay, so now we just solve this. Now we can choose to bring this a this side. So this is negative 4a will be equals to 36. So a will be negative 9. So the question I said, find the value of 9, we found the value. So find the value of a, found the value of a. Then now this question says the expression b plus x minus 4x squared gives a remainder of negative 19 when divided by this, and a remainder of 2 when divided by this. Find the values of a and b. So the first thing we always write the expression minus 4x squared plus 8x cubed. What is it? It gives a remainder of negative 19 when divided by, so x plus 1 q plus the remainder. But for this question, we've been given the remainder, so let's rewrite this. 8x cubed is equals to x plus 1 into q plus what's the remainder? Negative 19. So we can even just rewrite it as b plus ax minus 4x squared plus 8x cubed is equals to x plus 1 into q minus 19. So we say x plus 1 is 0, x is equals to negative 1. By that we are eliminating this, then we can substitute this here, b plus a into negative 1 minus 4 into this plus 8 into negative 1 cubed is equals to, since this went, so we now have is equals to negative 19. So what do we have? B minus a minus 4 minus 8 is equals to negative 19. So we have b minus a minus 12 is equals to negative 19. So our final answer becomes b minus a is equals to negative 7. We can call this equation 1. Then now we go to the second part of our question. That say the expression gives a remainder of this when divided by this and a remainder of 2 when divided by this. So now go to the second part. 4x squared plus 8x cubed is equals to, this term is being divided by 2x minus 1, it's giving a remainder of 2, so I can just add 2 here. So I equate this to 0, I get x is equals to half, so I just substitute this. So this is into a half minus 4 into a half squared plus 8 into a half cubed is equals to this one, so this is equal to 2. So I have b plus a out of 2 minus 4 times 1 out of 4 plus 8 times 1 out of 8 is equals to 2. So this goes with this goes with this. So we end up having b plus a out of 2 minus 1 plus 1 is equals to 2. So what we have, b plus a out of 2 is equals to 2. So I can multiply 3 by 2. What do I get? 2b plus a is equals to 2. So this is our equation 2. So what do? We just solve 1 and 2 simultaneously. So I'm going to hope we can all do this. I'm just going to quote the answer. Okay, this answer here, this is supposed to be 4. This is supposed to be 4 because we're multiplying 3 by 2. So when you solve, our value of a is 6, our value of b is -1 after solving the equation simultaneously. Then we have when the quadratic expression, this is divided by this and this, the remainders are. So this is the same concept, but just that here the variable is p instead of x. So we are going to bring this ap squared plus p plus c. When divided, first time when divided by p minus 1, what's the remainder? The remainder is 1. So p minus 1 is 0, p is 1. I substitute p in. So we have this plus c is equals to 1. So a plus b plus c is 1. I can call this equation 1. Then now I have ap squared plus bp plus c. This is equals to p minus 2 into q plus 1. Equate this to 0. P is 2. I substitute this in. This is 2 squared plus b into 2 plus c is 1. So what do I have? 4a plus 2b plus c is 1. Then now I call this equation 2. Then now the third one is the same equation, but this time when it's divided by p plus 1. What's the remainder? 25. So p plus 1 is 0. P is equals to -1. So this is -1 squared plus c is equals to 25. So this is a minus b plus c is equals to 25. This is equation 3. So now here all we have to do is to solve a, b, solve equation 1, 2 and 3 simultaneously, and the answer we get is going to be the answer that solves the equation. So I'm not going to do that. I'm going to refer anyone who has issues with solving simultaneous equation. I'll refer to our video on solving simultaneous equations. Then yeah, you'll see how we got our answer. So these are the 3 equations we have. So we get a is 4, b is -12, c is 9. But the question asks us to determine the factors of the expression, so we have to substitute for. So this is 4p squared minus 12p plus 9. So this is our quadratic equation. And yeah, this should be now clear on how we can now use any method to find the roots, then you find the factors. So we found after factorizing, you realize these are the factors. Okay, now we have this, the expression px power 4 plus q, this has a remainder of this when divided by this. So it's the same pattern for all these questions. Qx cubed plus 3x squared minus 2x plus 3 is equals to what is dividing this, what is the remainder? The remainder is x plus 1. So the same thing we've been doing, we equate this to 0, so this becomes x squared minus 3x plus 2 is equals to 0. So now we can use any method to solve this, but and what we will get, you can work this out. You'll get x will be 2 and x will be 1. So now we can substitute. Since here we have two values, we are going to first say when x is 2, then we now substitute. We bring it here, 2 power 4 plus q 2 power 3 plus 3 into 2 squared minus this plus 3 is equals, this was 0, but now we are also substituting here for the value of x2 plus 1. So now we open this. What are we going to get? We are going to get, this is 16p plus 8q plus, I think, plus 11. Plus 11 is equals to 3. So our final equation will be 16p plus 8q is equals to negative 8. So this is equation 1. Then I will come and say, how about when x is 1? So here we say, I'm substituting into the original equation, plus 3 into 1 squared minus 2 into 1 plus 3 is equals to 1 plus 1. So this is p plus q plus 3 minus 2 plus 3 is equals to 2. So our final equation will be p plus q is equals to negative 2. So this is our equation 2. So we solve equation 1 and equation 2 simultaneously. Our answers will be p is 1 and q is negative 3. So you can use any method to solve the simultaneous equations. Then here we have, what is the value of a if 2x squared minus 6, comma, this and this have a common factor. So I think we've done this number before in our chapter on quadratic equations. So what's the trick here? We have 2x squared minus x minus 6, and then we also have 3x squared minus 8x plus 4. So we first solve, because this one has an unknown, so we first solve these two and find their roots. Then we can also find their factors. And because of limited space and time, I don't want to make the video very long. I'm going to just put the factors I found after factorizing, but you can use any method. So this is what I have, and then x minus 2 for this. Then for this one, the factors you get are 3x minus 2, x minus 2. So from this we can see the common factor is x minus 2. So now we can now work out this. And what a question means, but what like a factor means is that when you divide that number by that term, you get a remainder of 0. So if this is a factor of this, that means when you do this, the remainder will be 0. So you say, but this is 0, x is equals to 2. So here we have a, sorry. So here we can finally find the value of a. We shall get a is 3. First get 8a minus 24 is 0. Then we get a is 3. So now you're going to try out these numbers, this and this. So you can try out those two numbers and see. So here the common factor, maybe I can tell you the common factor will be x plus 4. That will be the answer you get here. The common factor is x plus 4. The value of a will be 26. So you can use that to mark yourself.